information to you is that your test corrections, you probably won't see me after Thanksgiving break. So you should prioritize doing your test corrections while I'm still here because I love to help. Okay, and then the other sad news is that the sub that they've had planned all along to take my classes has now made a weird list of demands and they've decided they're not going to pick him anymore. So it'll be fine. But if you don't have a math person, even more so, let's get the test corrections done so that it's not like a question mark later of how capable the adult in this room will be. You know what I mean? Okay, but either way, I already have all your notes videoed. All your homeworks are set up. You'll be able to work together. I have 2 teachers available for you to go to tutoring for. So it's going to be just fine. But don't wait until after Thanksgiving break to correct all your tests because you're not going to have time and you may not have a capable adult helping with that. Okay? But it's okay. It's going to be great.
What were the demands?
I honestly don't know, but he basically said, like, this is what I will do, this is what I won't do. And Mr. Williams was like, we're not taking you then. So they just told me yesterday. I would have told you sooner. Yes, Aslan?
We do corrections with some of the other teachers?
You can, but it just might be a little bit more messy if it's like a random sub. I'm going to show him where everything is for Miss Hancock, formerly Miss Bess. But it would be better for you to do it while I'm here so that I can fix your grade and do the things that need to happen. Okay? So if you wait until after, I'm not saying it couldn't happen. It'll just be a lot less convenient, if that makes sense. Okay? All right, so we're on our next unit. Implicit differentiation is when you're taking derivatives for functions that are not solved for y equals. Okay, so all of the equations we've taken derivatives of so far, it's been like y equals and then this equation. So will you just peek ahead? Do you see that for these equations down here, the x's and the y's are just kind of mixed up? They're maybe on the same side or maybe they're next to each other. So implicit is where you have kind of like a mixed up equation that's not in a nice, neat y equals format. Okay? Here's what you're going to do. Here are your steps. Step number 1 is you're going to take the derivative with respect to x. We're going to call that d dx. Okay, now up until this point, all that I've told you is that d dx means take the derivative. Okay, and it does, but specifically it means to take the derivative with respect to, oops, this should say x. So that's why there's like a little x down here at the bottom. When you take the derivative, you're going to do it on both sides of the equation, and anything that has a y on it, you're going to attach a dy dx. Now, for right now, you don't know why that is. That's fine. Okay, but just remember, if it has a y and you're taking the derivative, you're going to take the derivative and attach a dy dx. Okay, step number 2 is you're going to separate. Any terms that have a dy dx are going to go to the left. Any terms without a dy dx, you're going to push to the right. So dy dx's go left, everybody else goes right. Step number 3 is that you are going to factor out the dy dx out of all of the left terms. This step should be possible because the only terms that get to stay on the left have to have one of those in the first place. Okay? Then you're going to divide to solve for dy dx. dy dx is the slope or the tangent slope of the graph at any point. And then when you plug in a particular point, you're going to do this notation right here, which I'll show you once we do some examples. Okay? All right, so let me show you kind of what I mean. This should not be like a super hard day if you understand how to take derivatives. So take a look at number one. We have a big long equation. We're going to take the derivative on both sides. So I want you to put d dx around the whole thing. Okay. Nice, easy power rule here. What's the derivative of 2x6? 12x5. Now, if it's an x term, you move on to the next. So what's the derivative of 3x squared? Great. Move on to the next. What's the derivative of minus 5y3? And then you're going to attach a dy dx because it was a y term. You're going to do that anytime you take the derivative of a y thing. Okay? Next one, we have a minus y squared. It's multiplied behind it, correct? So y squared, what would the derivative be? 2y and then dy dx. Because it originally was a y, and all of my y's are going to leave behind a little dy dx footprint. Okay, 10, what's the derivative of 10? 0. Okay, because it's a constant. Okay, next step. So number one was we took the derivative. Now we're going to separate. Left are going to be with dy dx, right are going to be without. So who does not have a dy dx? Which terms? Yeah, these two. So I'm going to push those across to the right side. Now the other terms are already on the left, so I'm just going to leave them where they're at. So I have a minus 15y squared dy dx. I have a minus 2y dy dx. And then if those other two terms are going to go across the equal sign, then I'm going to have to change their sign. So if they were originally both plus, when you cross them over, they're going to both be minus. So you have a minus 12x5 and a minus 6x. Everybody good so far? Okay, step 3, what does it say? GCF, both of the terms on the left should have a dy dx in common. So I'm going to take that dy dx and I'm going to GCF it out. So it's going to be dy dx, parentheses. And then I'm going to leave whatever is left behind in that parentheses from each term. So it'll be a minus 15y squared, minus 2y, and then keep the other side the same. So we took the derivative, we separated, we GCF'd. What's the next step? Step number 4. Divide. So you're going to take what this is and you're just going to divide it across on both sides. So that your dy dx is now by itself. So dy dx equals, these would cross out because I divided that whole parentheses out of the way. So dy dx is alone. And then this would be your answer. Now, could I pull a negative out of the top and the bottom? So I'm going to go ahead and do that just because that's like literally a negative on every term. So this is now a positive 12x5, a plus 6x, a plus 15y squared, and a plus 2y. Now, one thing I want to point out is that when you take the derivative of an implicit, remember how the x and y's were all mixed up? Okay, well now in your derivative, you have both x's and y's. The reason that that matters is that now, in order for you to find the slope, you're going to need an x and a y to plug into it. You can't just find the slope at 5 because that would only tell you what to plug in for x and you would still need a y. Okay, which we'll get to later. So let's do the next one. Do your derivative step all the way across. Remember, anything that has a y in it, you're going to drop a little dy dx on the end. So x3, what's the derivative? 3x squared. Okay, next I have a 2 sine. What's the derivative of sine? 2 cosine 3y. And then I need a little chain rule on that because it's not just 2 sine y, it's 2 sine 3y. So what's the derivative of 3y? Extra times 3, then I attach the dy dx. Okay, so that one term I'm going to write did need chain. Okay, so the extra times 3 at the back is from chain rule. Okay, then I have a 7y. What's the derivative of 7y? 7, then I attach a what? Dy dx, because it was originally a y. What's the derivative of e to the x? E to the x. And then 8x squared on the other side, derivative is 16x. Notice anything that was already a letter x, I don't attach a dy dx to. Okay, which terms are we going to keep where they're at? The terms that have what? Keep the dy dx's, so this guy's gone and this guy's gone. The other two guys are going to get to stay because they have the dy dx that lets them stay on the left. So I'm going to have 2 times 3 here. Can we multiply these together? So that would be a 6 cosine 3y. Are we okay with that? 6 cosine 3y dy dx plus 7 dy dx equals, I already had a 16x, I'm minusing a 3x squared across and plusing an e to the x across. Remember, when those terms cross over the equals, you have to switch the sign. Okay, then from there, what's my next step? GCF, good. What are we GCFing out of the left? They both have a dy dx. So I'm going to pull that out. That leaves me with a 6 cosine 3y plus 7 equal to a 16x minus 3x squared plus e to the x. And then remember, the reason we pull that dy dx out is so that we can divide that big parentheses to get rid of it. So this would go on bottom. Okay, and then if you want to be lazy on this left side, you can just cross it out if you don't want to write it on the bottom. Okay, really it should go there, but if you cross it out, that's good enough. Okay, but up to you. And then notice that your dy dx equation has both x's and y's. So if you were to want a slope, you would need to have an x and a y to plug in together. You couldn't just plug in an x. Okay? Turn the page. Okay, and then obviously if you're looking at this packet, we're not doing this all today. This will take us a couple times. Okay, number 3, can you go ahead and start it for me? So it says to find the slope. We know slope means take the derivative. So go ahead and give that a shot. Remember, anything with a y, you're going to drop a dy dx on the end. Will any of those terms require chain rule? Which one? Okay, the very first one. So that one's going to need chain rule. So I'll give you a sec to try it, then we'll do it. So cosine goes to what? Negative sine 4x times an extra what from chain rule? 4. Do I need a dy dx? No, because it was already x stuff. Okay, next term, I have a 2y squared. Derivative goes to 4y what? E to the x goes to? And 8 goes to? 0. 4y dy dx is the only guy that gets to stay on the left. Because if both of the other terms don't have a dy dx, they have to push across. So my sign was originally negative, so is my e to the x, so that when I bump those over, they'll both be positive. So I have a positive 4 sine 4x and a plus e to the x. Now, on the left side, if you only have one term, you can kind of skip the GCF step because it doesn't really make sense to GCF something out of only one term. Okay, but what am I gonna divide to get dy dx alone? Yeah, just the 4y to get rid of. And there's your equation. Okay, so dy dx equals 4 sine 4x plus e to the x over 4y. Okay, and then remember that that's the slope at any point that I want. Okay, but notice it's not at any x value because I'm going to need an x and a y to find the slope. All right, let's go on to part B. Part B says to write the equation of the tangent line at the point 0, 2. Now, there are two things that I need to write the equation of a tangent line. What are they? Okay, a point, which will require an x and a y, and a slope. Very good. Now, I already have the point. So for the slope, this is how you're going to label it. Put dy dx, vertical line, and then the point that you're going to plug in. So my ordered pair is 0, -2. Okay, and the reason you have to use that notation is because you can't just put f prime at 0, because like I said, you need both coordinates. Okay, then from there, we're just plugging those in right here. Remember, 0 will go in as your x, -2 will go in as your y. So it'll be 4 sine 4 times 0 plus e to the 0 over 4 times -2. 4 times 0 is 0. What is the sine of 0? This whole term then is going to go to 0. Okay. So I'm just going to box that and put 0. Is e to the 0 also 0? No. No, that'd be 1 over what on bottom? So that's my slope. And then once I have those two ingredients, I can write my equation, my tangent line. So it'd be y blank equals blank x blank. Remember, your -1/8 goes in true to sign, your x and y go in as opposites. Now, technically, since your x is a 0, you wouldn't have to put it, but I'm going to. Okay? All right, try the next one. So go ahead and take the derivative first. Watch out for a chain rule. You should be doing chain rule on one of the terms. So sine will go to what? Cosine 2x times an extra 2. Do we need a dy dx? No, because it was already x stuff to begin with. Next term, what's the derivative? 6y dy dx. What happens to the 12th? Okay, and then 5x goes to 5. From there, who are we moving across to the other side? And if it used to be positive, then when we bump it over, it'll be negative. So it'll be a 5 minus 2 cosine 2x. And then last step, divide by the 6y. Good with that? All right, that's the derivative for any point that I want. In part B, it says, find the point where your x is 0 and your y has to be positive. Okay, do you remember when we were doing equations of tangent lines that if they only gave you the x, to find the y, do you remember we just plugged into the original? So right here it says use the original equation if they only give you part of the point. So if they only give you the x or they only give you the y, that's okay. It's fixable, but you have to use the original, not the derivative. So I'm going to rewrite this right here. We had sine 2x, but now I know that my x is 0. Plus 3y squared minus 12 equals 5 times 0. But notice, where are we plugging in? Not to the derivative, to the original if you need the other half of the point. 2 times 0 is 0. What's the sign of 0? 0. So this term is going to cross out. Same for 5 times 0. That's also 0. So I'm left with 3y squared minus 12 equal to 0. How could we solve that? Yeah. Yeah, I'm going to plus that 12 across. 0 plus 12 is 12. Then divide by the 3. 12 divided by 3 is 4. And then how do I get rid of the squared? Take the square root. Now remember, technically when you square root, it's plus or minus. But then in this case, they're telling me which of the twos to pick because I want my y to be what? Greater than 0. So then I know that I'm going to use 0, 2. Okay. So we found the point. Then in part C, we're going to write the equation of the tangent line. So remember, we only need 2 ingredients, a point and a slope. We have the point from part B. Now we're going to find the slope. So dy dx, vertical line, 0, 2, because that's what we're plugging in. And then remember, any x's I have, I put a 0 in. Any y's I have, I plug it into. And I'm plugging into this guy right here. So it'd be 5 minus 2 cosine 2 times 0 for my x. And then 6 times 2 for my y. 2 times 0 is 0. What's the cosine of 0? 1. So if that's a 1, then I have 5 minus 2 times 1 is 2. So it's 5 minus 2. 3. And then 4 times 2 on bottom is, 6 times 2 is 12. So that would reduce to a 40. And then remember, once you have your point, you have your slope, you're ready to write your equation of your tangent line. So y blank equals blank x blank. I have a minus 0 for my x, minus 2 for my y, and a 4th for my slope. Questions on that? Okay. Go on to number 5. Take the derivative for me. Okay, first question, are you going to have any chain rule? No, not for number 5. So go ahead and do that derivative for me. Give it a shot. Anything with the y, you're going to attach a dy dx. Anything with the y, you're going to attach a dy dx. There are quite a few y's, so you should have a few dy dx terms. Oh, yeah. Yeah, here's your test, you read that.
Very good. No one expects when it comes. Describe point where you slow the support.
Yeah. Yes, because it originally had a y. That's a good.
So this is 0. Chris, no. Yeah. Yeah, something 0. What's the 0? No.
Okay, so that should be your first step. Okay, then good question. The 12y, even though it does power down to not have a y anymore, if it originally had a y and you took the derivative, you still attach the dy dx. Okay, then from there, I'm going to do the next 2 steps in one. I'm going to take the dy dx out. And also, I'm going to push the 2x across to the other side. So these three guys all had a dy dx, and then this guy had to move across. Okay, from here, you would divide that term across. Say that again. Huh? She answered you? Okay. Yeah, because they're not like terms. Okay, so that's what you should have for part A. Okay, for parts B and C, you are going to get questions in this problem set, okay, where you're asked to find where the slope is horizontal and where it's vertical. Okay, if your slope is horizontal, that means that your slope needs to equal what number? Sure. Which is okay for it to be 0. Now, in part C, you want your slope to be vertical. Where would the 0 have to be? On bottom. So if you want a horizontal slope, you're going to set the top of the dy dx equal to 0. If you want it to be vertical, you're going to set the bottom equal to 0. Okay, so I'm going to put here, this is set top equal to 0. This will be set bottom equal to 0. Now, for the top, what is your equation? Just a 2x. Then I would let 2x equal 0. Divide by 2 on both sides. What would x have to be? 0. So your description would be any point where x is 0. Now, if it said that you have to find the coordinates of the point, that would mean an x and a y. You would have to plug that x equals 0 back in and find the y that goes with it. But if it just says describe, then just giving an x value is fine. Okay, go on to the next one. We want the bottom equal to 0. Is there anything that I could go ahead and take out of the bottom to factor it? Yeah, so it'll be y squared minus 1y minus 2. And then what will times to 2 and subtract to 1? For like an AC chart moment here. 2 and 1, and then where will I put the negative? On the 2 side. So if I want a negative 2 multiplier, I can only use 1 times 2. I'll put the negative on the bigger number. So my equation would be a y with a plus 1 and a y with a minus 2. But then remember, my solutions, if I solve by factoring, are the reverse of those signs. So I would say any point where my y is equal to negative 1 or positive 2. But because it says describe the points, you're not actually going to have to go back and find the x's that go with that. That would be a good enough description. Okay. All right, we're going to skip number 6. Yeah, you're done now. Yeah. You can't correct it today because I still have people that need to take it, but you can start on Friday.
Did I do the CIA correction today?
I still have people who need to take that again. All right, go ahead and turn the page again to number 7.
6?
Yeah.
Just like I don't want to do 6 to go 7.
I know 6, 7 should go together, but
this is what
all right. Okay, you're skipping all the way to number 7. Okay, maybe we'll just do like 7 and 8, and then
We don't have a.
maybe we'll be in a good spot.
6 and 13.
Disappointed.
Oh, just don't worry about the numbers, okay?
Oh, there is a 7.
Oh,
all right.
She has like 6 plus 7. Oh.
Bad number ones.
Oh.
Okay. Okay, on number 7, do you notice that you have a term that has both x's and y's together?
Yes.
Okay, so you are going to have to use product rule for any terms where you have x's and y stuff that are multiplied together. So let me just remind you, you just took a test over product rule. Okay, but you break it down to u times v, and then you do u v prime plus v u prime. Okay, but any term that's mix and match with x's and y's, you're gonna either be doing product rule or quotient rule based on if the x and y terms are multiplied together or whether they're divided. So on this one for number 7, I want you to underline the parts of your product rule. It's a 2x multiplied by a y cubed. And then I'm gonna put PR at the top for product rule. So my u is a 2x. My v is a y cubed. All right, let's take the derivative. What's the derivative of 2x? 2. What's the derivative of y cubed? 3y squared dy dx. Very good, because remember, if you took the derivative and it had a y in it, you attach a dy dx. From there, let's do our product rule. Remember, order doesn't matter. Just make sure you get both of them. So I'm going to do the easier looking one first, is the 2y cubed. Plus, for the other diagonal, is it okay if we times this 2 and this 3 together? So what would that really be here? A 6 xy squared dy dx. Cleaner on the end. Good with that? All right, after the product rule term, I have a minus 4y. What's the derivative of that? Just a minus 4 dy dx. Okay, notice that the y that it had, when I power it down, it drops out. And then for the 6, it's going to drop to a 0. Okay, only dy dx's get to stay. So who's going to get sent to the other side? These are going to stay, and who's going to get sent across? 2y cubed is going across, which means now it's a negative. So I'm going to go ahead and do these 2 steps at one just to save our little hands the writing. Okay, but it's going to be a negative 2y cubed. And then from the left side, I'm going to pull my dy dx out of the 2 terms that are staying. So I'm going to have a 6xy squared and a minus 4. Why does which one stay?
Why is the x negative 2x cubed to the other side? Why does it get the other side?
Because it doesn't have a dy dx.
Or is it not?
Because in the product rule, this piece, neither one had a dy dx. Okay, remember guys, when you do product rule, these are the original pieces, and then these are the derivative pieces. So my original y cubed didn't have, I hadn't taken the derivative yet. The derivative is what puts the dy dx on the 3y squared. Does that make sense? Caleb, you had a question? Sure. Okay, then from there, divide your 6xy squared minus 4 across to the other side, and you'll have your answer. So it's dy dx equals negative 2y cubed over 6xy squared minus 4. Okay, next question. It says find the point where y is 1. Where do I go for the point? The original or the derivative? Original. So take 1, you're going to plug that into the original equation. So it was originally a 2xy cubed. Now it's a 1 cubed. Minus 4y is a 4 times 1 equal to 6. Okay, 1 cubed is still a 1. 1 times 2x is 2x. 4 times 1 stays a 4. Next step. Get rid of the minus 4 by plus 4. 6 plus 4 gives us a 10. 2x equals 10 means that x is 5. Now remember, why do I need the other half of the point? Because in order for me to find slope, I have to have a plug-in value for the x and the y. So for part C, we want the equation of the tangent line. We need two things, a point and a slope. The point is an x of 5 and a y of 1. For the slope, you have to label it with the weird line thing. So it's going to be slope dy dx, vertical line 5, 1. And then we're plugging that into our equation. So it'd be -2, 1 cubed, 6 times 5 times 1 squared minus. Do the top for me. Following PEMDAS, how's the top going to come out? -2. Okay, on the bottom, this is going to be 30 take away 4, which is 26. And then I'm going to reduce that to 1/13. Okay, then once you have those ingredients, you can write your equation of your tangent. So y blank equals blank x blank. X and y's go in as opposites. And your slope goes in true to sine. So it'd be a -1/13. Okay, we're going to do one more and then I'm going to have you start on your homework. Okay, so look at the next one. I want you to pinpoint which piece of the equation needs product rule. Okay, very good. The middle. Now, when you highlight your pieces or underline your pieces, it's not an x squared. It's a minus x squared. Remember, we want to include the subtraction in the product rule. So for that piece that needs PR, okay, I want you to make sure that you include the negative in the product rule. So let's show our work for that down here to the side, then we'll write out our derivative. So my u is a what? -x squared. My v is a? Do you need me?
I'm sorry, I just want to question.
And you're coming 5th, right, to our PLC? Okay. Is that okay?
Absolutely.
Okay, thanks. No worries. All right, then what's my derivative for -x squared? Okay, very good. For my v prime, remember, it's a y. So when I take the derivative of sine, it goes to cosine y dx. But remember, this top piece doesn't have a dy dx because I hadn't taken the derivative yet. These are the original pieces that were multiplied. Okay, so now you have your product rule ready to go. Remember, you're taking the derivative of the whole thing. So go one term at a time. What's the derivative of 2y? 2 what? dy dx. Then I get to my product rule. I can write whichever diagonal first that I want. Usually I'll do the one that doesn't have the dy dx first. So it'd be a -2x sine y. And then a -x squared cosine y dy dx. Okay, so I did the 2y. I did the product rule. What's the derivative of x plus 6? Just a 1. And then from there, who's going to get pushed across which term? Because it doesn't have a what? dy dx. That's why it has to move. Then the remaining guys, you're going to pull the dy dx out and then divide across. So go ahead and finish that off for me. So I'll have a 1 plus 2x sine y on the other side. So it should look like that. And then your parentheses ends up on the bottom. Okay, two more little parts here. We want to find the point where x is 0. Where do we plug in for the point? Okay, use the original. I'm going to plug in that I know that my x is a 0, so that'd be 2y minus 0 squared sine y, and then 0 plus 6. So 2y. Okay, then if this is a 0 times sine y, what's going to happen to sine y no matter what? Yeah, that's going to just cross out. That's also going to cross out, so 2y equals 6, which means that y is what? 3. So my ordered pair is 0, 3. Okay, but remember, original gets you the point, derivative tells you the slope, which is what you'll need for your tangent line. Okay, then it says, write the equation, the tangent line that you found. So dy dx, vertical line, 0, 3. Because remember, I have my point, but I still need my slope. And then I'm plugging that into my dy dx. So it's a 1 plus 2 times 0 sine 3. 2 minus 0 squared cosine 3. And then why do I not care that I have no idea what the sine and cosine of 3 is? Yeah, they're going to times by these zeros anyways. So my slope is just going to come out to a what? 1/2. Okay? Then from there, write your equation, your tangent line. Y blank equals blank x blank. So it'd be a minus 3 here, 1/2 in the middle, minus 0 here. Okay, then I want you to look at, I can't remember if this is on today's homework or next time's homework, but if you're asked, we have one more little piece. We almost finished part C, but we didn't. It says to write the equation of the tangent line. Did we do that? Yes, okay, then it says use your model, that's this line, to estimate what f of 0.1 is. All that you would do is take the 0.1 and plug it in where your x is. So if they ask you to use it, okay, you're just going to plug it in. Now, one thing that we hate is a fraction times a decimal. So quick question. If I'm going to put a 0.1 here, what decimal, because I don't want to mix and match fractions and decimals, what could I replace the half with? 0.5. Okay, technically they're the same, but if I'm plugging in a fraction, then I love that this is a half, because I know how to times fractions with each other. So if it's a decimal, switch them both to decimals. Okay, from here, what's 0.1 take away 0? It would be 0.1. Okay, then to multiply decimals with each other, what's 5 times 1? 5, but you would have to move the decimal, so it'd be 0.05. And then you would add the 3 across. So your final answer would be 3.05. Okay, and we'll practice that more next time. I think that's on next time's homework, not today's. But just a little intro that if you have to use the tangent line, you're just plugging in the number, the decimal in the parentheses. Okay? All right, we're going to keep going with these notes next time, but for now, let's do some homework. So get on to your Delta Math for me, please.
I heard they get late.
Okay, you should be able to see it now.
Apparently they get. It's time to think. Every time I do. Yeah.
Would you like scrap paper? Yeah. Yes.
All for the ones that are there, then it'll be passing.
So you'll have time next time if you need to go back and finish this one, you can.
I was just saying, like, have we covered all the topics?
You have covered everything that's in this one.
Alright.
The level ones, none of them have product rule, and then the level twos is where you have to.
Level 3, then. I'm going 3.
They're level threes at next time's homework, not this time. Y'all, for level ones, you should have no product rule. When you get to level twos, there might be a product. Y'all want paper? Yeah. Do you want paper? Ben, you want this down? So do you like the paper? Alex, you want some?
Cheating.
Yeah, will you email me so I don't forget? And you don't even have to, you just say, we take off our stuff. And you all need paper? You just email me to take off. It's probably because it's showing up, but I'll take it without this. Don't be worried.
November, I've been thinking scout. November. I've been thinking. I forgot.
It's actually 6 days. This, so underline this is your use this. Hey, but remember the core stays the same.
I know, that's all.
Outside layer. So it'll come all the way down. Yes. Keep it the same, then reduce the power, and then remember the middle sort of in time to be this. This one is project rule, and then this one. Just make it sure that the sign doesn't have its own, it's usually what things like. Give that one for now, do the other. Claire, how are you doing? Good? Okay. Yes, how we doing? How we doing? Okay. And you know, this one needs to teach us that these equal and look at your brain. And times by correct. Yes? If you have a negative. So what you have.
Do the number line.
Read it to me into mine.
Number line.
Okay, so if you wanted to take the negative out, I think this, yeah. So you have. And then. That makes sense, but you can't just take two ways, that's. Yeah, and don't have.
Yeah, I know.
This is correct. Yeah.
Negative quote X.
But you're wrong.
Where over. Some more words. Over. I just didn't know. It's a hard one today, you're right. Yeah. Spuds. That's like, so you have. So you don't spreads. It's like someone right there.
Oh, shit, wasn't this a negative? Oh, you can't do that.
6, 7.
Here's why, look at what I just read it. If you wanna take the negative off the top and a negative off the bottom, you can't just take the negative off the worst. You'd have to pull the negative out from the bottom, so your 4 would go positive, but your 2 wide. Does that make sense? And then. But you can't just take 1 off the bottom, you have to take.
You're 6 over 8. Technically, that's why you're 6 here.
Yeah.
So.
Y'all still do
So negative 2y, what's the derivative? Negative 2, attach a dy dx, because it had a y. Just write a dy dx. After. Okay, then your negative y squared, what's the derivative? Negative 2y, and then you're gonna attach a dy dx to the back, because it was originally a y. Okay, next term is a minus x squared, what's the derivative? And it was originally an x, so you don't have to do the weird dy dx. And then equals it. Okay, from there, anything that doesn't have a dy dx, you're gonna move across the other side. With your minus 2x, circle it. We're gonna bring that across to the other side, which means now it's gonna equal a positive 2x on this side. Okay, good. Then from there, GCF out of dy dx from the left side, so write dy dx parentheses. Just in the next line. And then you basically, here, let me show you, Caleb, you have this. So your dy dx is in the front now. And then I believe you already had a minus 2 and a minus 2y.
Yeah.
Like that. So you're pulling it out from both. And then to get dy dx by itself, you're just gonna divide this to the bottom. So you'll do divide by negative 2 minus 2y, negative 2 minus 2y. This is the answer that you'll type in. And then if you type the slash first, sometimes that makes it easier to type in. Yeah.
Yes. Make sure that's the.
Okay. Okay. Can you show me 0 to 0? Okay. Yes. Yes. Yeah.
Oh.
And then over what is your? Because you have to remember the version of the top and the bottom. So you did the top. The bottom.
Whoa.
Because on bottom you didn't do it next. But you're doing it right. L'Hopital's rule says take your pieces and try the X error. And then I realized. So you did go back.
That's just my.
And then this one, what do I factor in? So in that case, me, I think L'Hopital's rule is clear. And remember, only L'Hopital's rule that you're plugging in 0. Remember, the 2x under the and then you times by an extra. So each 2x stays, here's 2x, then you go in a layer. So and then remember. Let's get started on our homework, Oswald, you little silly guy. Yes, sir. When the 12 moves over, equal positive. When you scoop over to the other side, now it needs to be a minus. And then you have it ground. Hey, did you say something? No, you didn't. Caleb, here's your, oh, sorry.
Wait, so we
You gave me the CIA review. You have your review for the test. Oh, yeah, okay. You can just, can you give it to me next time? That's right. Or if you want to bring it by tomorrow, if you haven't finished, or later today, that's fine too. Yes. Trevor, CIA review.
I love.
On today. Sure. Y'all, the extra credit was out of 10. And if you didn't get all 10 and you want to redo it and turn it back in, I'll do it. Who did this? 6, 7. You little Billy Goose. And see what it says.
5, 6, 7.